we have a set of data to begin with, that is we have a database, and then we give one or more interestingness criteria, and the output of which will be one or more hidden patterns which we didn't know exist in the first place. Now given this model, we should say, now when we say patterns, then the obvious question to ask is, what type of patterns? What do you mean by patterns? Or what do you mean that this is, or when do you say that something is a pattern and something is not a pattern? Now if we have to answer that, we have to ask two further questions, that is, what is the type of data that we are looking at? Okay, what kind of data set is it that we are looking at, and what is the type of interestingness criteria that we are looking at? What do we mean by interestingness? Is it a correlation between something? What exactly do we mean by interestingness? So let us look at the different type of data that we encounter in different situations. The most common kind of data is the tabular data, or the relational database, right, which is in the form of a set of tables, or now the slightly different multidimensional form of database. And it's very common, that is any kind of transaction data, that is let us say data coming out from the database at from an ATM, for example, or the data coming out from the transactional database at a railway reservation counter, or at a bank, or any place like that, are all tabular in nature. So it's the most common form of data, and which is a rich source of data for to be mined. In addition to tabular data, there are spatial data, for example, where data is represented in the form of either points or regions which have been encoded with certain coordinates, x, y, z coordinates. So each point, in addition to having certain attributes, also has certain coordinates, and mining in this context also requires us to know what is the importance of the coordinate system. In addition to spatial data, there are other kinds of data, like say temporal data. Temporal data in the sense that where each data element has a time tag associated with it. So temporal data could be, for example, streaming data, where network traffic, or set of all packets that are flowing through a network forms streaming data, which just flows past, and where each packet can be allocated some kind of a timestamp, or something like activity logs. Your database activity log is a temporal data. There could also be spatiotemporal data, that is data that are tagged both by time and coordinates, and other kinds of data like tree data, which for example XML databases, or graph data, where especially biomolecular data, or World Wide Web is a big graph data, and so on. Then there are sequence data, like data about genes and DNAs and so on, and again activity. I mean, sequence is a kind of temporal data where timestamp need not be explicit in this in sequence. Then text data, the arbitrary text or multimedia, and so on and so forth. So there's several different kinds of data that we can that can be the source which from which we can extract or mine for unknown nuggets of knowledge. Similarly, when we talk about interestingness criteria, several things could be interesting. If certain pattern of events or certain patterns of data keep occurring frequently, then it might be of interest to us, something that happens very frequently. Okay, so frequency by itself is a interestingness criteria, or an interestingness or a criteria on which interestingness can be based. Similarly, rarity. If something happens very rarely, and we don't know about it, or let us say rarity is again a very interesting pattern to be searched for when we are looking at say abnormal behavior of any system, or abnormal behavior of network traffic, and so on. So something that happens rarely, that is away from the norm, is again an interestingness pattern. Correlation between two or more elements, and if the correlation being more than a threshold is again interesting, or length of occurrence in the case of sequence or temporal data and so on, and consistent occurrence, consistency, that is consistency is different from frequency in the sense that overall in the set of all databases, in the overall for the entire database, a given pattern may not be frequent enough. For example, there could be one particular behavioral pattern. Let us say one particular customer comes to a bank every month at the 10th of each month, right? So if we are looking for frequently banking customers, let us say, this customer would not figure out in this algorithm, because this customer comes only once a month, whereas other customers could be coming many times a month. However, if we are looking for consistency in behavior, then this customer's behavior is far more consistent than someone who comes, let us say, arbitrarily 10 times the first month, and once the second month, and 50 times the third month, and so on and so forth. So in terms of consistency in his behavioral pattern across different months, this pattern is interesting, even though it's not frequent. Then repeating or periodicity is slightly similar to consistency, except that periodicity is consistency is across the entire set of across the entire set of months, if we have divided our database into months. But periodicity, the time interval could vary in a periodicity of a pattern. If a customer comes, let us say, 5 times to the bank every 6 months, we may not be able to catch it as part of a consistent pattern analysis, but if we use an algorithm that detects periodicity of several occurrence of events, we will be able to detect it. And similarly, there are several other patterns of interestingness that which one could think of.